to LearnCity. My name is Praise, and in today's class, we'll be talking on mutually exclusive events on probability. Mutually exclusive events on probability. Now, two events are said to be mutually exclusive if they cannot both occur simultaneously. The Venn diagram below represents the situation in which sets A and B are mutually exclusive or disjoint. Now, these events are said to be mutually exclusive. They are mutually exclusive since the probability of A is equal to probability of B, which is now probability of A union B. So this shows that two events are mutually exclusive if they cannot both occur simultaneously. They are two different things. They cannot occur simultaneously at the same time. Now, under addition law, if events A, B, C are mutually exclusive, the probability of A or B or C happening is the sum of their individual probabilities. Now, when we want a probability to be of mutually exclusive event, where we have three different events, each of the probabilities has to be added together to make them mutually exclusive. So if events A, B, C are mutually exclusive, the probability of A or B or C happening is the sum of their individual probabilities. That is P of A plus P of B plus P of C. This shows that they are mutually exclusive under addition law. Now, complementary events. We need to recall that E is the complement of a set. So we have it to be probability of E will now be 1 minus probability of E, or E complement. Here we have probability of E complement will now be 1 minus the probability of E. So we have it to be 1 minus probability of E. Now, an example. A number is chosen at random from the set 2, 4, 6 to 20. Find the probability that it is either a factor of 18 or a multiple of 5. We have a number which is chosen at random from this set 2, 4, 6 to 20. So find probability that it is either a factor of 18 or a multiple of 5. Now, to solve this, we have our total numbers to be 10. Now, writing down the numbers we have to 20, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have the total number to be 10. We have the total number to be 10. So the factor of 18, we are looking for either of a factor of 18. Which is any number that is divisible by 18, that can go through 18. So we have 2, we have 6, and we have 18. In these numbers, we have 2, 6, and 18 that can easily go in 18, which shows that we have it to be 3. So the number of numbers that are factors of 18 is 3. So here, probability of factor of 18 is now 3/10. That is the probability of factor of 18. Now, for the multiples of 5, in our numbers, we have 10 and 20. For multiple of 5, we have 10 and 20. We have it to be 10 and 20, which is 2. So we have it to be 2/10. So we have it to be 2/10, which can either be 1/5. So we have it to be 1/5. That is either a factor of 18 or a multiple of 5. Now, either a factor of 18 or multiples of 5, which is either of the two, then we add both numbers together. It will now be either factor of 18 or multiples of 5. We now have it to be 3/10 plus 1/5. So we have this to be 10. We have 3. This is 2. So we have this to be 5/10. Then we have this one. This is 2. So we have it to be 1/2. So for either it is a factor of 18 or a multiple of 5, we have it to be 1/2, which is 5/10, which is 1/2. Now, for independent events, 2 events are said to be independent if the 2 events have no effect on each other. For example, the task of getting both a 6 and a tail in a throw. They have no effect. It's like throwing a die and a coin. These 2 events have no effect on each other. A die will basically bring out its own number, and a coin will bring its own number. So an example under this: 5 girls and 3 boys put their names in a box. So we have it to be 8 names in a box. One name is picked out at random. One name is picked out at random. When one name is picked out at random without replacing the first name, a second name is picked out at random. What is the probability that both are names of girls? So the first name that is picked out at random, which is a girl, will now be 5/8. It will be 5/8. Now, the probability that the second name is picked as random without replacement will now be 4/7. 4/7. That is, the name was not replaced. So definitely we already have 7 names here. So the remaining 4 names is now 4/7. So that is probability. So the probability that both are names of girls, we now have it to be 5/8 times 4/7. So we have it to be 20/54. Okay, 56. So we have 2 here to be 10. 2 here is 2. In 16, it is 8. 2 here 5. 2 here 1 and 4. So we have it to be 5/14. So the probability that both are names of girls is now 5/14. And this brings us to the end of our class on complementary events, independent events, and mutually exclusive events. Subscribe to our YouTube channel, like and comment, and I'll be seeing you in the next class. Thank you.